What's up everybody, how's it going? Last week I posted a video tutorial for my pathfinding visualizer project. That was a video that a lot of you had requested, it was really well received, and I actually had quite a bit of fun rebuilding that project. So I figured, why don't I complete the series and do the same video for my sorting visualizer project. This is another project that I showcased in that one video I did a while back on the software engineering projects that got me into Google. If you haven't seen it, I'll put the link in the description below. I'll also put the one for the pathfinding visualizer tutorial below. But anyway, so this is going to be that. I'm going to be doing a sort of tutorial for the sorting visualizer project. I say sort of because someone in the pathfinding visualizer tutorial rightfully called me out and said that it wasn't quite a tutorial. Agreed, it was more of a build this app with me type of video, so that's what this is going to be. I still think you're going to be able to basically rebuild this project after you watch this video. I'll also put a link to the GitHub repo of this tutorial that I do right now in the description below. So with that, sit back, relax, and let's build this sorting visualizer. I'm going to give myself about 2 hours. I actually think that I can get this done in 2 hours, maybe even faster. Let's start by defining what it is exactly that we're going to be building. So this is the actual sorting visualizer project that I had built about 3 years ago now. As you can see, it's pretty simple. It's just one page. You've got this button to generate a new array. When you click it, as you can see, you have a new seemingly random array that consists of these like upside down bars here in the middle. It looks like we have a slider to make the array either bigger with thinner bars or smaller, and apparently that affects the sorting speed. And then finally, we've got 4 popular sorting algorithms: merge sort, quick sort, heap sort, bubble sort. And when we click one, we have this sort button that's kind of weird here. I think I had developed this on a bigger screen back then, and I hadn't taken into account responsiveness. But anyway, you click the sort button, and as you can see, we can visualize the algorithm. So I think I'm going to build this generate new array button for sure. That way people can regenerate an array whenever they want to restart the app, so to speak. We're definitely going to have the array in the middle. I do think that I'm going to represent the bars right side up, so upside down compared to what you're seeing here, just to make the project a little different, and maybe I'll change the colors a little bit. Then we're going to do these 4 algorithms as well. We might even do insertion sort if I feel like it. Spoiler alert, this was a lot more difficult than I anticipated and took a lot longer than I thought it would, so I ended up doing only merge sort in this video. The rest of the algorithms are going to be for you to implement on your own. But merge sort will be the basis, and it's what we're going to be covering in this video. Sort of like in the pathfinding visualizer video, we covered Dijkstra's algorithm, and the rest of the algorithms were up to you to implement. I don't think I'm going to do this slider. I think this slider isn't really too important for the project, and I think I'm just going to go with a lot of bars in the array, just because I think this is the most cool to see, to visualize when there are big arrays. And the last thing is, I think that when you sort an array here, you can see that there are actually a few colors happening at once. There's like a red and a green. I'm not really sure why I had that. I think what I was trying to do, like if we take a smaller array here and we do like bubble sort, I think I was trying to say like, if they're green, they're already in order. Like you see here, they didn't turn red. They were just both green, so they were already in order. And then when they turn into purple, that means that they are actually in sorted order. I think I'm just not going to complicate myself too much here, and I'm just going to do something like whenever we're comparing 2 values in the array, make them a certain color, and then when we have a value that is in its final position, we'll make it into another color, like maybe purple. So that's what we're going to build. We're going to do exactly what I did for the pathfinding visualizer tutorial, which is that we are going to use React to build this, and it's going to be very simple. Even if you don't know React, I think you're going to be able to follow along and pick up React as you go. So if you Google create a new React app and you click on the first link, I think you should go to this reactjs.org link, where you have a very, very easy way to just bootstrap a React application. Make sure that you have these versions of Node and NPM installed on your machine, and then all that you have to do is run npx create react app, and then the name of your directory. So for this project, I called my directory sorting visualizer. Then you can get into that directory, npm start, and what you'll have is this React app here on your local host 3000, and here you'll see I added a bunch of like gibberish just to see that it works. So if I go to my Visual Studio Code, I have it right here. This is the auto-generated file or files that they've given me, and I'm just gonna start by cleaning it up and removing this entire header here. And this is where we're probably going to have our sorting visualizer component that I still have to create and import. But so this is the very beginning of the project. Right now, if I save this and we go back here, we get an error because sorting visualizer is undefined. But so this is where we're going to start. And at this point, you can probably forget about all the other files that they generate for you. You're just going to create another directory in source here. It's going to be sorting visualizer. And that is where all of our files are going to live from here on out. All right, so I'm going to go ahead and create this sorting visualizer component, start filling it out with what I have in mind, and then I'll walk you through it in about 10 minutes or so. Okay, so just taking a quick pause here. Basically what I've done is I've created this sorting visualizer component as well as sorting visualizer CSS file that we import here. This component is then imported in our app component and it's just rendered in the app. I think I had that right before. And then in the sorting visualizer, what I'm doing is I've got an array stored in our state. This is going to be our main array. And in the component did mount, so when the app loads or when this component loads for the first time, we call this reset array method here. And of course, this reset array method is going to be the same method that we call when we click on the generate new array button. So it'll be reused there. This method literally just creates an array. It iterates 100 times in a for loop. You could use a while loop, whatever you want. And it pushes a random value between 5 and 1,000 in the array. And then finally it resets the state to have this new array. Now for this method, you might have seen in the little time-lapse thing that I literally just Stack Overflowed how do you randomize a number in JavaScript in an interval. I can never remember how to do it. As you can see, it's a little bit like involved. You need to do math.floor, math.random, multiplied by a bunch of stuff. But anyway, we've got the method here, and I linked the Stack Overflow article that I used to get this method. I literally copy-pasted it from there, and I'm just trusting them. And by the way, the reason that I'm doing a value between 5 and 1,000 as opposed to like 1 and 1,000 is because I think I remember from around 3 years ago when I first built this that if you do something like 1, let's say you get an array of value 1, you can barely see it on the screen depending on how big you make the bars. So I'm just going to go with 5. It doesn't really matter. And by the way, as an aside here, we are allowing duplicate values in these arrays, which is fine, or if not even good, because when you're sorting arrays, you want to have duplicate values. Your sorting algorithms should handle that. And finally here, as you can see, I am iterating through my array and mapping all of the values to literally just these divs that have a class array bar that I haven't defined yet. So this is just like a non-existent class for now. I put this key property with the index just because in React, if you don't put a key property in values or elements that you've sort of rendered in an iterable, you get a little warning in the console. So that's why we put that there. And then finally, we put the value in the div. And so because there are no styles right now, all that we have is literally just a bunch of numbers. As you can see, a bunch of numbers, one after the other. So that's our app for now. And if we refresh, like you see how the top number is 224, then 789, these are random numbers. So if we refresh, we have different numbers, 514, 392, and so on and so forth. So now what I'm going to do is I'm going to try to add a few styles just so that instead of having these random numbers, we have bars on the screen, and I'm going to have them, instead of having them pointing down, like here you see how they're pointing down, I think I had wanted to do pointing down just because it looked kind of cool, like you know, like ice picks coming from the ceiling or something, but I'm going to do it the opposite direction here just to make it a little bit different. CSS time. Wish me luck. I literally can never remember how to center something vertically in a page. Alright, I'm just going to use position absolute and top 50v height to put it like down in the middle of the page. Alright, so basically this is what I have so far. It's kind of hacky, but this was very much like experimental. I have my array container, which has all of my array bars here. It's this container div that literally is position absolute, and it's got a position from the left of 100 pixels that explains this side here. And then I have 310 bars in the array. Just so happens that 310 bars of 2 pixels roughly fit the entire screen. Again, this is very hacky. I'm kind of hard coding everything just because I want it to look good, but there are many different ways that you could do this. You could probably try to find the dimensions of your screen and calculate things according to that. Here I just kind of want to have the thing working and looking good for you. Then I made every array bar of width 2 pixels, and I gave them a margin of 1 pixel on the left and 1 pixel on the right. So I guess there are 2 pixels between every single bar. And I gave them a width, I gave them a background color of pink. I can change that. We could do like blue, right? And it'll just look differently. For now, I'll probably just, maybe I'll keep the blue. And actually, this is kind of a gross blue. Let's do like turquoise. Yeah, that's a little better. And then in the React part here, I also gave, I gave a style where for the height of the bar, I put the value, the value in pixels. So basically, that means that big values of, maybe like, I put the values in between 5 and 730. By the way, I reduced it from 1,000 because I'm literally using that. Like if I put 1,000, I'm using that to position like the array. So if I put 1,000, it moves it further down in my screen. Again, very hacky, but 730 seems to be good for this. And yeah, that's how I'm basing the height for this thing. So now I guess what we can do, oh, and I removed the value because like at first I had the value here, right? Value, and you see it kind of like messes things up because it tries to fit in the value in an element of width 2 pixels. So yeah, we don't need the value. By the way, as a quick side note, I am not going to be referencing my old project at all. I will be putting the link to my old project in the description below, but I do want to just try to rebuild this from scratch and see like how I do right now in like, an hour or two. All right, so now I'm going to add all of the buttons. I'm probably going to add them at the bottom, so right below our array right here if I have space, and it's going to be the button to generate a new array and then all of the sorting algorithm buttons, and after that we will jump into the actual sorting algorithms. But let's do the buttons first. We've got our button. Alright, so our generate new array button works. Literally it's just a button with an on-click event handler that has an arrow function. By the way, we use an arrow function because we need to have the this context here. I'm not going to really go into this, but this is something that you need to know when you're doing React. You want to make sure that you're keeping the this context with your sort of callback functions. But anyway, so we have this reset array function here that we just call on click of this button, and that just calls that one function that we called in the component did mount. So that's how we can reset the array very easily. All right, so now I have all my other buttons, merge sort, quick sort, heap sort, and bubble sort. Whoops, I still have a new here, I need to remove that. And basically I created 4 methods in our component, merge sort, quick sort, heap sort, bubble sort, and they are gonna call helper methods that are gonna be the actual algorithms, and then we're gonna do the animation. So now what I'm gonna do is I'm gonna jump into actually writing the algorithms. Let's see if I can actually remember off the top of my head, or like, rework, rederive merge sort, quick sort, heap sort, and bubble sort. I'm going to start with merge sort, and then I'm also going to create some sort of way to test that my sorting algorithms are actually correct before I animate them. So let me try to derive merge sort, let me try to do the testing, and I'll get back to you in about 5 or 10 minutes, however long it takes me to create merge sort. Okay, I'm actually starting the algorithm now. Okay, so I think that I have my merge sort working. I went with a kind of, how can I say, like not the most optimal version of merge sort in terms of space complexity at least, like I'm recreating a bunch of arrays. That being said, I do think that this should work. I haven't reread my code yet. I'm gonna write some tests for this and see if it works. For the tests, what I'm going to do is I'm just going to very sort of naively create a bunch of arrays with a ton of values, like a bunch of randomized arrays, like the ones that we have in our main file. And I'm going to call the JavaScript built-in sort method and compare the value that I get from that to the value that I get from my sorting method and see if it's if the values are the same for, you know, a ton of arrays of like 1,000 randomized values. See you in 5 minutes. Okay, so basically what I've done is on click for the merge sort, I filled out the merge sort method. What it does is it creates a new array called JavaScript sorted array, which is literally a copy of our main array, the one that we have here in our app. Okay, I have a problem, I'll look into that in a second, but we sort it using the built-in JavaScript sorting method. Then I do sorted array, this is going to be the one using merge sort, equals merge sort this.state.array. By the way, I guess, yeah, I imported sorting algorithms, so it'll be sorting algorithms.merge sort. That should fix this. No, it does not. I think it's because I need .js, maybe? Okay, I'll fix that in a second. But the point is, I have my sorted array here using merge sort, and then I console.log arrays are equal, passing in both arrays, and this is a method that I just created here that literally just says, hey, first check if both of these arrays have the same length, and then iterate through both of them. If you ever find a value that are, if you ever find at one index that the values are not equal to each other, return false, otherwise return true. So we're about to test this out, but first let me fix this issue that I'm getting here. Okay, so are you ready? Let's see if we get, we should see in our console, we should see true, that the arrays are equal when I click merge sort. False. Okay, so they're not equal, so I have a bug. Let's see if we can debug it. Let me look at my merge sort algorithm real quick. Okay, so I reread my algorithm. I'm getting the impression that it is correct. I'm not sure where the bug is. Let's start to debug by putting a console log here. We're going to console log sorted array. So it does look like it's sorted. Let's see when we hit false. Okay, so they're not of the same length. Oh, I was comparing... Oh my god, I was comparing the length of array 1 to array 2. I have to do array 2 dot length. Okay, it's still false, but now let's see why. Okay, so it is actually working. The other bug was that in my native JavaScript sorting, I didn't pass a sorting function. So here you see how I pass now a minus b. In JavaScript, you have to pass a sorting method, otherwise it will sort in such a way that for numbers, the number 100 will come before the number 5 because the 1 of 100 comes before 5. It's a confusing thing. You can look it up on the Mozilla documentation, but that's why it wasn't working. So basically, I actually did have a correct merge sort right off the bat in about like 5 minutes of coding it. So I will pat myself on the back for that. Let's just make sure that this is actually working. I am going to remove this console log, and what I'm going to do is I'm going to generate a bunch of new arrays and keep merge sorting every time. So merge sort, generate new array, 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 merge sort. Okay, so it seems like it is working. There's probably a more robust way of doing this. I should probably generate a bunch of arrays to test this out, but I think it's working. So I'm just going to move on now. Before we move on to quicksort, maybe now would be a good time to do the animation. But actually, you know what? For peace of mind, let me just write a slightly more robust way of testing this because it's a little sketchy. Okay, so basically what I did to test this out is I added another button called Test Sorting Algorithms, and that's going to test all of our algorithms. What it does is it iterates from 0 to 100, so it creates 100 arrays. Every array is going to be of a random length between 1 and 1,000. So basically we might have an array of length like 1,000, we might have an array of length 33, we might have an array of length like 700. Actually, let me move this. Let me do this. I'm not sure. We'll do const bound or length equals random int there. That way I forget if like in a for loop, the upper bound is computed every time you iterate. Anyway, so we'll do, yeah, the length is going to be a random integer between 1 and 1,000. And then we push a random value between negative 1,000 and 1,000. And once we've populated the entire array, we create the JavaScript one that sorts with the JavaScript built-in method. We create one that's sorted with merge sort, and then we console log whether the arrays are equal. So we've got 100 arrays like this, and if I do it here, test sorting algorithm, you can see that we keep console logging true every time. So like clearly now we're literally testing with some robustness. So now let's dive into the animations. So for these animations, I think I'm going to have some sort of a wrapper method above the algorithms that basically calls the algorithms and then returns whatever values we're comparing at any given point in time, because we're going to want to sort of color those values. And then that returns when the values are in final sorted order. So let me try to play around with it, and I'll get back to you in a little bit. So I have to take a quick break here. I guess I didn't explain to you how I did merge sort, and now I'm realizing that I'm probably going to have to refactor it. So the way that I had done merge sort is basically at any given point in time, we find the middle index of the array that we're dealing with. We call merge sort recursively on the first half and then on the second half, as you can see here. And then we iterate through the first and second half, and we take the smallest number every time and sort of merge the two arrays. So that's how merge sort works. If you want a better explanation of this algorithm, then check out algoexpert.io. This is a perfect plug for my company. algoexpert.io, use the promo code CLEM for a discount. We definitely cover merge sort and all of the other sorting algorithms. So this is how I did it. Now I'm realizing that we're going to want to populate or to like keep track of the animations in this algorithm. This is why I added this animations array here. Now we need to know the index of the values that we're comparing when we're in the final array or in the original array. In other words, we can't pass down to this merge sort method sliced arrays that are just like smaller versions of each array, because we will lose the index of these values in the original greater array. So what I'm going to have to do is I'm going to need this merge sort method to take bounds rather than to take an actual array, if that makes sense. So let me refactor this and get back to you in like 10 minutes. Okay, merge sort is going to be a lot more complicated than I realized. I'm going to go grab a snack and try to think this over, because I think this is going to be a lot more complicated than I thought it would be. Okay, so I think I figured it out, but I'm going to cheat a tiny bit. I'll tell you what that means in just a minute. Let me try it out, let me make sure that it works, and then I'll get back to you. Okay, so I think I should take a pause here and kind of explain to you what's going on, what I meant by I'm cheating a little bit, and so on and so forth. So as I said earlier, I mentioned that for the merge sort algorithm, it's a lot more complicated than I expected it to be, and than I remembered it to be, because we need to know what place in the original array we are at when we're comparing two values and we want to like color them, and when we want to swap them. We need those positions because we're going to try to grab the array bar in the DOM that corresponds to that position and change its color, or both of their colors if we're comparing multiple things, change their height values. Now, with our very original version of merge sort, where we were just creating new arrays, new smaller and smaller arrays, which is sort of the naive version of merge sort. We explained it on AlgoExpert. It's got a worse space complexity. That just didn't work. So then I was like, okay, we need to have indices that keep track of like where we are in merge sort. And I quickly realized that if you want to do merge sort that way, you end up kind of screwing yourself, because you're going to be overwriting values in the merge sort array. And so basically you have to use the much more complicated version of merge sort, which is also the most optimal version of merge sort, which again, we cover on AlgoExpert. But what I meant when I said that I cheated is I literally just went on AlgoExpert and copied the better version of merge sort. So here, I don't have time. It's like 1:25 a.m. right now already. I didn't think this would take that long, but I copied that version of merge sort, so I commented out my original version, and this version of merge sort uses like an auxiliary array that you keep swapping with like an auxiliary array where you can override values and your main array. It's pretty complicated, but that's working. And so then what I did is I added this animations array, and the merge sort function basically returns an array of animations rather than a sorted array. And at every point in the do merge part of this merge sort method, we add to our animations array a given animation. And so what I'm doing is I'm saying, hey, whenever we're comparing values, like here we're comparing auxiliary array at index I and auxiliary array at index j, when we're comparing values, I create an animation that's going to have a comparison property that's going to hold these two values, I and j. Those are going to be the two values that we want to color at any given point in time. And then, and this is where things start to get shaky, and I'm not sure if my logic is correct, when we want to swap values, or we want to like overwrite a value at a specific index, I'm adding this swap property to my animation. And so here that holds index k and I, but I'm not sure if k is actually correct here. So like, I'm putting a pause on that for a second. And so now we go back to the animations. So our merge sort method, what it does is it says, hey, get the animations by calling merge sort on our array. And then this is where things get really tricky, right? I'm iterating through the animations. I'm grabbing the comparison and the swap. And the first thing that I want to do is I want to set a timeout that says, hey, every 10 milliseconds, but remember, this is a for loop. So this for loop happens synchronously, like it happens instantly in JavaScript time. So at each index I, we want to multiply the delay of the set timeout by that index. And we're doing 10 milliseconds by that index. And so the first thing that we say is we say, okay, have the two comparison bars change colors to red, for instance. And so if I undo this code here, you'll see that like this works right now, right? I've got my array merge sort, my array. I click merge sort, and you can see that like it's turning values that are probably meant to be compared to each other in red. Now you might notice that there's some weird like delay sometimes. Like here you're like, what is happening? Why is there a delay? And the reason there's a delay is because right now we're not actually swapping the values in terms of animations. And there are multiple times in merge sort where you recompare values at specific indices. So, and because we're leaving the values in red, that's what's happening. Like there are animations that we're just not seeing because I'm keeping the values as red. Now I have to try to figure out how to like time the unredding of the values or of the bars and making them go back to turquoise, but it's really complicated. This whole set timeout thing is just completely confusing with the delay, with the like for loop and all that. So that's what I'm trying to figure out. I'm gonna give it a bit more thought and get back to you in a second. And I still didn't get that snack that I said I was gonna get, so maybe I should do that. But I'll be back in a second. Okay, so here's where I'm at right now. I think I have most of the stuff working, except one thing. Like I said, this is much more complicated than I thought, and I think that because it's getting so late, I'm probably gonna actually stop after merge sort, or maybe I'll do quick sort, but I'll probably stop after merge sort and leave it as an exercise to the viewer to do the rest of the algorithms. This is probably the toughest one. But basically, so I had my animations, right? In my animations, we had said for every animation, we had a comparison, meaning two values that we were comparing. And then we had two values that we were swapping, okay? And I had called these like dot comparison and dot swap. Now, the swap, if you remember, is the one where I was like, I don't know if this is actually correct to swap like K and I, and that's the part that I'm like not sure is working. The other part, the comparison, what I did is I iterate through all the animations, and I say, I'm gonna push to some new animations. Very hacky, I know. I'm gonna push my comparison twice. And the reason is, when we're gonna then iterate through a for loop with an actual set timeout, we're gonna say, using the, index mod 3, basically we know that every 3 values we have like a new start of a new animation. If we're at the first of a triplet, then we change the color to red, because that's when we're like comparing two values. If we're at the second thing of a triplet in our new animations, we change the color of those same first two comparison values back to turquoise. So, we put them as red, we're comparing them back to turquoise. And then for the third one, that's when we do the swap. And if you look at my animation, I generated an array of a bit smaller, like 100 values instead of 310. If I click merge sort, let's generate a new array. If I click merge sort, it looks sort of correct-ish, except for the swapping. Like the swapping is just not correct. And that's where I think I messed up the swapping animation. But like, look, if I remove this swapping animation, so I remove this, and let's make it back to 10 milliseconds instead of 5 and 10 here, you'll notice that like it actually looks correct. Like we're comparing what seem to be correct values, I think, right? In merge sort. So I need to figure out what I'm doing incorrectly with the swapping. I think it's because like when we swap those values, we're not actually swapping, we're overwriting one value, but not actually swapping. Okay, I'm gonna figure that out. I think I'm actually gonna take my little break now and go get my snack, and then I'm gonna try to figure this out. But again, like I said, I think I'm gonna stop after merge sorts. Hopefully I can even get through this tonight. All right, so I was just eating my midnight snack, cereal with milk, gotta have it, and I had my little eureka moment. I think I figured it out. Basically, we do not wanna swap values because that just ends up being incorrect in the merge sort algorithm with this auxiliary array thing. What we want to do is we just want to say, hey, we are overwriting one value with the other, and that's it. So it's not a swap. It's not a swap of two values. It's just one value being overwritten. So let me see if that works in the code, and I'll see you in like 2 minutes. Okay, I think I have it. Let's test it out. Let's try to see if it works. So we're gonna go here, we've got our array, let's generate a new array, and the moment of truth. That does not seem to be working. Wait, it's not even moving anything. Wait, what? I swear this is supposed to work. I swear I had my eureka moment, this is supposed to work. Why is nothing... bar1 style.height. And earlier, we were moving stuff earlier. Oh, because we're setting the height to a number, and here we were setting the height to be another height. Okay. Oh my god, JavaScript bugs. This needs to be a string of a value with px after, pixels. So it's going to be new height, pixels. Okay. Ready? This is gonna work. Oh, you can start to see the merge sort shape. I think we have it. Yes, I think we have it. Yep, that's the merge sort shape. Let's just let it finish, watch our work happen. Beautiful. And we can even speed this up. Let's speed this up to like 5 milliseconds. Beautiful. Beautiful. We can even see what happens if we put like a bigger array now, 310. Maybe we should put like 3 milliseconds. This might start to get janky. And let's have our value, yeah, okay. So 310, let's merge sort this out. No, it works. 3 milliseconds is perfect for something this large where you need it to be fast, otherwise it gets boring. Wow, this is super cool. All right, I'm pumped. We got it to work. And then here, after this, we could do the animation, like, to put sorted values in purple, but, like, I think that's going to be fine for now. We'll probably leave this as is. I'm really happy with how this, like, turned out. What I'm going to do now is I'm going to clean up the code, because right now there's a lot of like weird shit happening in these animations, and then I'm going to kind of re-walk you through all of it, and then, sorry, I've got something in my eye. And then we're going to probably call it, because this took way longer than I thought it would. Lesson learned, don't underestimate anything. I don't know why I was like, oh yeah, the sorting visualizer, like now that I've done pathfinding, which was like the tough one, this one is going to be super easy. No, this one is actually like, I would say this one is tougher. This was tougher than the pathfinding visualizer. Admittedly, I didn't reference my old code, but still, this felt like it was tougher. But yeah, I'm going to clean up everything, re-walk you through it, and then we'll probably call it. And I think that for the rest of the algorithms, like quicksort, heap sort, bubble sort, you can probably do it on your own. They shouldn't be too different. They will have a slight difference, like in the algorithm functions themselves. You'll have to figure out where to put the animations and like how to, like, do you have to do a swap? Because like in quicksort, you actually do have to do a swap. In merge sort here, you're just overwriting a value, but in quicksort, I'm pretty sure you're gonna have to actually swap two values. But we will leave it as an exercise to the viewer. So let me clean up the code and I'll be back. Okay, so I cleaned up a little bit of stuff, not that much. Basically, in the merge sort helper, I now push all of the animations. So if you remember, if you were paying attention closely earlier, I started pushing like multiple animations in the sorting visualizer component method, where I was like recreating animations for the comparison. Here, basically, I'm saying, okay, when we get to a point where we have to push, let's say IJ multiple times, we're going to do it here once and then a second time. And I'm being like very intentional with the comments. It's even a bit overkill with the comments, just so that if you pull this repo or fork it, you'll have everything you need. And then we do the same thing with the swapping here, or not the swapping, sorry, the overwriting thing, where we say, hey, we're pushing the value at index k in the original array, which is going to be overwritten by the value at index I in the auxiliary array. So we're passing this value here, right? Auxiliary array at index I. And so we keep doing that everywhere here. There's a lot of repeated codes and comments. And here then in the sorting visualizer, everything is pretty trivial, right? The reset the array is very trivial. I created a couple of constants here that you can change if you want to edit stuff very simply. But the merge sort method basically says, hey, let me get all the animations. I renamed the merge sort method in sorting algorithms to get merge sort animations. Iterate through all of the animations. Whenever you're at an animation, grab all of the new array bars that are currently in the DOM, grab them through their class name, check to see if we're dealing with a color change. That happens for the first two values of every 3 animations. So if when we mod the index by 3, we've got a remainder that's equal to 2, then we know that we're dealing with the overwriting thing. Otherwise, we have a color change. If we have a color change, then we know that the 2 values of the animation represent the 2 indices of the 2 bars that we're looking at. Depending on the position of the animation in a triplet of animations, we're either going to have to turn the bars into red or turquoise or whatever your colors, whatever you want your colors to be. And maybe I'll turn that into a constant as well. And then finally here, if we're dealing with something that is not, if we are at mod 3 equals 2, meaning we're dealing with overwriting a value, then we know that the values in the animation are the index of the bar that we're going to be overwriting and the new height that we want to give that bar, meaning the new value that we are overwriting it with. We just do bar1 style.height equals the new height in pixels, and that's that. And we've got our set timeout with the animation speed in milliseconds, and it just works. Let's just confirm that it works after I cleaned up all of this stuff. So merge sort. Yep, looks like it works. And I'm sure we can do this even faster. Like, let's see if we move this to 1 millisecond. Let's see how fast this becomes. Yeah, super fast with 1 millisecond. Kind of cool. Kind of looks cool. So now you can play around with this. You can change the colors as you please. Like here, okay, very quickly, we'll just change the colors from, we'll put this as like Well, I'll do this after, actually. That's going to be it for this video. I really hope that you enjoyed it. Like I said before, I'm going to be pushing the code for this project up to a GitHub repository so that if you want to fork it, you can do that and you can create your own version of this project. I'll put the link in the description below. And now I guess I'm going to go try to edit this video to get it out for you by tomorrow, which is when you are currently watching this video. And of course, you know the drill at this point. Go smash the like button and subscribe to the channel if you haven't already. I will see you in the next video.